Alright, hello everyone. Can I have your attention, please? Thank you so much. Great. How was the food? Good. Energetic? Yes. Come on, show me energy. Alright, great. I'm going to talk about GraphRAGs. Has anyone heard about GraphRAGs before? Or RAGs in general before? Quick show of hands. Okay, a couple of you. Right. A quick introduction about myself. My name is Sid. I come from all the way from India. I work in Bangalore. That's my base at the moment. Originally from Delhi. Settled in Bangalore. Traveled across Asia Pacific and some of the other places as well in Europe. I lead developer relations for Asia Pacific at Neo. A bit on my career, I started off my journey as a Java technology engineer at IBM, but soon turned my passion towards community building, customer relations profession. And that's what I've been doing for the last a decade, more than a decade. I also lead GT Cloud Bangalore user group as well, one of the organizers. That's my LinkedIn handle if you wish to get connected with me. So I'll move on from here and talk about Neo4j and GraphRAGs. But a quick show of hands. Has anyone heard of Neo4j before? Worked with Neo4j? Okay, a couple of you. Who's not worked with Neo4j? It's okay. It's okay. It's okay. Fine. All right. Cool. Who's not heard of LLMs before? Anyone here who's not heard of LLMs? Initially, this slide used to say that who has heard of LLMs, and everyone used to just raise their hand and then they. Okay, everyone knows, but just want to understand if someone is there by instance who's not heard of LLMs. Okay, everyone has heard of LLMs, been using LLMs for work pleasure or in their enterprise development as well. So, I'm going to touch base. So, this is a talk is going to divide it into two parts. So, those of you who are super new to graphs, I'm just going to cover graphs in quick 5 to 8 minutes, and then I'll jump on to the actual part, which is the GenAI part. I have a couple of demos as well. So I'm going to be a little rush in the initial part, but I'll spend some more time on the GenAI side of things and how it combines with what XAI is. But that's going to be the topic. Okay, what's a graph? So if you Google graph, this is something that you get in the images section, but this is not what I am interested in. I'm actually interested in this, which is the graph theory, which you might have studied in your university days. So if you notice over here, there is something like circle, and then there's some lines that connecting circles, and then circles are connected to a bunch of lines. That's the foundation of graphs. If you've heard of Panama papers, that's one of the classic examples that I love to quote when I'm talking about graphs. So the folks at ICIJ, International Consortium of Investigative Journalists, they went back and they were trying to find out some shady systems that happens. How the cash flow is happening between various countries, companies, officers, blah, 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 and stuff. So, eventually they had 11.5 million documents, which is not just bank statements, but they were a combination of emails, scan documents, bank statements, and a bunch of other things. And then this entire piece was roughly 2.60 million size, but how do you find some connections between the data? How do you make relations between each of these documents? So what they did was they started with a small circle in the graph here as well. Okay, there's a person, there's a document in which there's a person named A has an account with a bank. The bank is in US, let's say. Now this person lives at a particular address, and at the same address there's another person B who lives at the same address. But now this person B is an officer of another company. Now this company has an account in a bank in Bahamas, and the money was getting transferred between the company, bank in Bahamas to a bank in US. But there's no direct way to find out that how this person A or person B is connected. This is a smaller version of it. Now, they converted these entire 11.5 documents into a graph structure, and eventually they found the bigger piece of the entire network out there. Okay, so coming back to the fundamentals, I said it's now this circle is what we call it as nodes. So nodes represent things in a graph, and they can be identified by one or labels. I've given a label over here as a movie and animated as 2 labels. And then these nodes can also hold data in the form of properties as key value pairs. So I have a key value here, which is title, and value as Toy Story, another one is released 1995. Now there will be 2 nodes which connects with each other, the relationship acted in. For example, I have Tom Hanks as one node with an actor node. The actor acted in a movie Toy Story. That's it. Now, if you notice over here, there's a type and then there is a direction. The direction is super critical in your project. You want to query from the database. Now, this relationship also holds data in the form of properties as key value pairs. For example, like you see the roles is movie. This is all theoretical. How does it work in real world? Now, think of it as you might be familiar with tables and rows and columns, right? The SQL database, the relational database, right? So the way you query in your relational database using structured query language, you query a graph database using a specific language. Cypher is a declarative language, which is a proprietary language, but ISO has invested in the last 40 years to come up with a standard language for all the graph databases out there, and they created GraphRAG language. This got launched in April this year, and everyone started migrating to GraphRAG language, providing support for GraphRAG language. Super proud to say that Cypher has contributed a lot to the development of GraphRAG language. So if you start with Cypher now, once everyone moves to GraphRAG language, your curve is going to be relatively easier for learning and for validation. So how it works, your circles are just your rounded brackets. Put your labels in the rounded brackets, and then your direction, your relationship type is defined by dashes, greater or less than sign based on the direction of the arrow, and the bracket is the put relationship type within that. Okay, P, R, and L that you see over here, these are optional variables that help you query your graph database faster. Now, how do you query? You can write to your 4J. You can create a pattern and say that, hey, this kind of pattern, just want to create this kind of pattern. An actor acted in a movie along with some values. So I can use the create command over here, or I can use a merge and combination merge and set command. First create all the nodes, then create all the relationships, then set the values to it. Okay. I can read from the database as well. I can find a pattern, filter it, and then choose what I want to return. But if you look at this query very carefully, this is very similar to what you do in your relational database as well. Where your map statements are similar to your from or your joins, and then your where remains the where, and then your return statements are essentially your select statements out there. So the recap. Wait, one thing. Just before that, why do you want to move from relation to graph? Why graphs really matter? I'm just going to cover it quickly. Now, taking the movies out of it again, imagine I have three tables, three areas, three categories, let's say directors, movies, and genres. Now, a simple one-to-one relationship between movie director and genre could be as simple as that. Now, a movie can have multiple directors as well. What would you wish to do? Either you create a new table with all the data, or just create a new table with totally all the keys and then start mapping it from there. That's the unnecessary complexity that you're bringing into your logic. But the movies can also have multiple genres, right? Now, I'm not going to depth of how do you do that, but I know that eventually if you have the data, it becomes super complex when you have to work with complex joins. You might have to avoid data applications when you start using joins. The clean support performance as well forces you with the strict schema. You can't change the schema every time. And that's the beauty about your project, about a graph. You can change the schema on the fly as well. You don't have to restrict yourself with whatever you create at the start and just change it later on as well if you need to. So a movie over here can have multiple directors, and a movie can also have multiple genres, as I said, giving you super flexibility in terms of handling your relationships, maintaining your data consistency as well, and then there's of course a built-in query language support. So this is a recap of how your relational to graph world will look like. You have your rows, which gets mapped to your nodes, joins maps to relationship, and your table names maps to labels and columns maps to properties. While I always recommend to start in a graph data modeling standpoint, like take a piece of paper or a whiteboard, just draw some circles, like whatever you think in your data could be the nodes, and the information that is in your data could be your relationship. Just start drawing it, and then later on put it into the graph database, like model it that way, or you start with anything and then later on change it. That's also an option for you. Okay, quick recap. overall summarizing what Neo4j is, it's not just a graph data platform, not just a native graph database, but we also have data science analytics capabilities. There's a lot of development tool frameworks. The first fact, Neo4j started off as an open source product way back in 2005. And still, we have an open source offering for you. And mostly all of our tools, frameworks, libraries, they start off as a open source projects and then eventually either be maintained or still be maintained by a lot of open source maintainers out there. There's a tool for discovery, which is GraphRAG, query language support. Okay. The last one is pretty important. Very interesting is that it runs everywhere. For those of you who might have worked with Neo4j maybe 5 or 6 years back, you might not be aware that, or if you have not worked in the last 6 years, that there is now a cloud offering as well. You can manage it within the cloud infrastructure from Google Cloud directly, or you can go to any of the, or you can just run your text files or Docker images on any of your cloud servers. Or the third option is that we use our cloud managed service. So we have something called as cloud managed service. Just go to our API. These are some of the popular use cases on graphs, but not just limited to them. But we feel that these are some use cases where graphs can play a real pivotal role. From here, I'll move on to the actual part of RAGs with Neo4j and Vertex. How do these two things come together? Now, we know that LLMs make things up, they're hallucinating, right? Essentially, what is happening is that they're working with only half the brain, which is the right side of the brain. They are imaginative, they have holistic thinking, resolution, they can create images, blah, 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 and stuff. Of course, there are some facts that they always talk about, but these are the facts which they're trained on. But how can we fix the other side of the brain, the left side of the brain, to make sure that it's giving us better response? So there are ways to avoid hallucination. One is your prompt engineering. Again, those who have worked with GenAI might know what prompt engineering. I'm not going to depth of how these things work. So prompt engineering is one method, context learning is one, third one is fine tuning. But the main question still remains, the big question still remains is, how can I provide my enterprise data to my LLM, or even if I don't want to expose it to the LLM, but how can I build GenAI applications which uses my domain specific knowledge and gives me better context response, right? Or experimental response. And this is where RAGs with Neo4j comes into the picture. So this is how a vector RAG will look like. Now, RAGs in general will look like. So you have your bunch of PDFs from your domain knowledge. Now what you do is you take these PDFs, divide it into text chunks, convert it to vector embedding, store those vectors in one vector database. Now when user queries it, you just tries to get a similarity score, a vector similarity score, ranks it, and then gives it to the user that hey, this is the response. This is it just feeds it to the user, feeds it to the LLM, and then generates an answer for you. What is changed over here? Okay, one second. So there are use cases where we feel that the naive vector search will fail this way. So imagine if I have a lot of contracts in place, and I have imagine 100 contracts, and out of those 100, 10 of them have the mention of Acme Incorporation, and probably 5 of them there's lots of mention of Acme Incorporation. But maybe just one contract exists out of those 100, where I'm actually writing a contract, like working with Acme Incorporation. Right? So in such a question, like if I have to find out like, what are contracts with Acme Incorporation, the chances the results might not be accurate over here. But there are more reasons where we feel that RAGs with vector search alone will fail, will fall short. The first one is that it leverages only a fractional. And the second, beyond a simple metadata, it fails to capture the hidden relationship between the data. It misses out on the critical context as well. So if I'm asking something which is a context description, and I'm going to show you as well in a while, it fails to answer it. So if the question is more like a multi-step question or a specific question, it fails to give a response. And the third one is that the vector search gives you a vector similarity, but it is not equivalent to LLMs. Does it mean that if I am asking something around acme collaboration, I want the word acme over there, like a keyword over there, or something over there? It has to find out the context. That are contracts with the acme collaboration more like a context over here? So the relevance over here. So that is missing. And the fourth, which is very, very critical to enterprise these days, is the explainability. Okay, getting a response, which is totally fine. Now, where is this response coming from? I want to know and understand how are you getting this answer to me? So that's something that's missing because of the black box nature of vector databases. So that's where GraphRAG comes. So essentially, like, GenAI, what you start with 70 lines of code with an API key, and then your expectation is that maybe I just do some model selection, some fine tuning, some parameter tweaking, and then I will achieve that. But the thing that we are missing out, or where the opportunity lies, is this knowledge graphs. And that's where the entire GraphRAG is based on knowledge graphs concept. We are not getting away with the vector search approach, but it's a combination of vector plus local graph traversal. Now, before I jump onto the GraphRAG, I want to introduce you to what knowledge graphs are about. Take this use case, for example. So here you're seeing probably a combination of 2 or 3 subgraphs. So there's this graph around people's recommendations or their likings or their. So at the start, the top last, like, what's your choice of ice cream flavor, right? So imagine like, your interests over here. So I have a graph which maps all my interests, and then I have a bunch of people who map between the interests. And then there's another subgraph which is around the location, places, and monuments, and then places to visit and stuff like that. We'll see how beautifully these two are mapped together. That James is somehow mapped to Louvre Museum, and then museum is in Paris, and then there's the Eiffel Tower, that's also located in Paris, blah 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 and stuff. Right? So knowledge graphs is nothing but like a combination of multiple subgraphs, which eventually makes sense to the entire data. Now, there are 2 types of graphs you can, if you really put it in that way. So one is your lexical document graph, the way you are doing it in your vector search, vector RAG. So you divide your, you put your entire graphs in chunks, and relationship between them in more like a graph structure. So that's a lexical document graph. The second type of graph is your domain or entity graph, which is more like a real or digital world representation of the data, with most in a structured data interface. Now, these 2 graphs are not mutually exclusive, but really are rather comes together. So if you see the first graph is more like a lexical graph, the second one is your entity graph, and see there's a mentions which is another relationship between, I don't know what here, which states that this chunk is connected with the other node or the other relationship out there in my entity graph. So that's what the summary of GraphRAG is, where you have the vector similarity search. Now you combine the vector similarity with the local graph traversals, and then on top of it, if you want additionally, you can also do graph database, graph data science based graph traversals. We have 70+ algorithms around computer detection, pathfinding, and stuff. So you can easily use those algorithms to get your work done if you have any of those use cases. And all in all, you can do everything within your full chain. We support vector search indexing. We also have graph data science algorithms. We also have graph database for your local graph traversals. So ultimately, you're fixing your LLMs by adding the left brain, by giving the left brain knowledge graphs, which gives you the facts, explicit knowledge, and experimental knowledge. When it comes to Vertex, this is how the reference architecture will look like. So you have your textual documents, it could be structured, it could be unstructured document. You use any other generative AI features provided by Vertex AI, put it into graph database, and there's a very interface where you your application, and then you query from the database easily with any of the generative AI infrastructure sitting in between. So to expand a bit on the generative AI infrastructure, so you have applications for business users, developers, and AI practitioners. So this is something which is of relevance to us, the AI platform and Model Garden. Model Garden has more than 150+ foundation models, domain-specific models, and everything. And then there is like agents and parameter tuning and stuff. You can easily do it within the Vertex AI Studio and Vertex AI platform that can help you achieve all the generative AI tasks. Again, I'm not going to go into the depth of how it works, but this is just for the reference. And ultimately, it's not just signing as a standalone database. You can rather combining it with any other open source framework, any other open source libraries, platform tools. Anyway. So you can take any of the generative AI embedding models from Google or anywhere else, combine it with the orchestration frameworks. You ultimately do the grounding with large charts and you push it out there. Okay, now this I have a demo, but before I show you the demo, I just want to quickly explain the demo as well. So my demo is in two parts. One is the structured data and another one is unstructured data. The structured data is, or both of them are for the publicly listed US companies where they are filing something called as Form 13 and Form 10K. So Form 13 is really simple. The information what the managers who own these companies. They get multiple asset managers managing multiple companies, and the multiple companies can manage multiple asset managers. Now, very basic information comes up. How many stocks, what's the value of the stocks, blah blah blah. When is it reported? So very basic mapping I can do like a manager owns a company, and that's what I did. Now with the unstructured data, it's kind of like 300-page report. Now imagine doing this for maybe 10,000 companies out there. So you have 10,000 into 300 pages, 300 plus pages for each of these companies. So that's the number that we're talking about. So you take all those 10K filings, which is more detailed report, and then you convert it to a medicine and sold it to your footage and all that stuff. Now you see over here, what's pretty interesting is my lexical graph is this, the document graph is this, which also has a connection with my entity graph, which is manager owns company. That the company has some reference to that particular document. Okay. Now, what I'm going to ask this particular chatbot is, I'm not sure how the data ingestion looks like, but after the data ingestion, I can ask questions like, name asset managers exposed to investments in regulated companies. Now, this will tell me both the results, one with the vector-only approach and another with the vector plus graph approach. Okay, so while the vector plus graph is generating a response, the vector-only approach says that based on the context provided, the asset managers exposed to investments in regulated companies are not explicitly named. Of course, because in our data, nowhere it says that, hey, I'm a regulated company and then I have these are the asset managers that are managing me, right? So the data doesn't say it explicitly, but rather it's a combination of first it identifies documents where there is a reference to regulated companies and then tries to map the relationship between those regulated companies and the asset managers if it kind of exists. So the vector plus graph approach is much more coherent, confident with the response. Saying that hey, private LLC is exposed to investments in several regulated companies across various industries. So my intent was to get the asset managers, not the regulated companies. So I got the exact responses which I was looking for. But I got the asset managers' needs, and that these companies are primarily investing, let's say, crypto exchange or financial services and stuff like that. Now, let's ask another question, which is another context situation, that which companies are vulnerable to lithium shortage. Again, the data might not say directly that, hey, I'm a company, I deal in this, and then we are vulnerable to lithium shortage. It has to figure out some sense from the data itself that what are the raw materials that these companies use, and then eventually what impact these raw materials or what impacts the supply of these raw materials maybe, or that's my core business. But this core business relies heavily on lithium shortage, so eventually if this goes down, then I would be impacted. If lithium shortage goes down, if there is a lithium shortage, then probably my impact, there's a huge impact on my entire supply chain as well. So let's look at what the vector-only approach says, that companies in aerospace, automotive, electronics, it's from industry names, but which of course usually use lithium-ion batteries, but there's no definitive answer to a specific company that's using that's going to be impacted with the shortage. Versus the vector plus graph approach says that this is one company, now this company produces this chemical product that requires magnesium rich as a key raw material. So lithium shortage could impact the supply of this raw material, which in turn could impact the company as well. Now we saw the mention of aerospace as one of the industries, but here I got a better confidence response that this is the company which operates on modern energy refinery, which produces conservation fuels. So this is one example I want to show about how a vector will act versus a vector plus GraphRAG, which one is better with a more practical approach.
So you see,
yes, that's. I also participated in the AI competition. I think the voting is closed now. But yeah, you can always go to this link and check out the demo which I did. It's a very Indian use case. One of the epics, probably one of the largest epics in the world. I tried to convert that epic into a graph structure to form some relationship. To give you an analogy, it's probably the historical. I should not say that. Let's just leave it. It's not a good analogy to put. But yeah, the reference was actually something around. So imagine if you have a Game of Thrones starter, how you can convert it into a graph structure and then put it into database to query. So yeah, you can always read about it, check out how it works, how it functions. But moving on from here, one thing which has always been a question from developers out there. Okay, I know that vector maybe not the viable solution. I would go with GraphRAGs. But how do I build knowledge graphs in the first place? Is there something which is an easy way to build knowledge graphs? I can of course code, but it takes a lot of time to identify the entities. But can you come with a solution to do that? So that I can just converse through the graph easily. So we built something called as LLM graph builder tool, which is simple to use, seamless tool, helps you get onto it quickly and easy. And of course, demonstrate the power of GraphRAG. Very easy to use, 3 simple steps. You start with your put your connection, put your data over there, and just click on the new graph. Literally as simple as that. I'm going to show you in a while. It took me less than 15 minutes to generate a graph for the entire trains and trams network in Melbourne. And I can put it within the tool as well, or I can just build another application out of it prepared for my graph. So once it generates, it just creates a graph like structure for you. It identifies the nodes and relationships and then converts it to the graph. You can of course do graph enhancement. You can always restrict the tool to say that, hey, don't be creative, just follow these nodes, just follow these relationships, and generate my graph based on that. Like add on to my graph based on this schema only. So let's look at the demo of how it works. In fact, the tool that I submitted, the chatbot which I submitted for the AI competition was built using this tool.
So which one?
Okay, so I used these two Wikipedia sources, France and Melbourne and Melbourne. Again, you don't have to restrict this to Wikipedia. The tool is open source, as I said. It's free. You don't have to put any of the keys out as well until now. You can play around with PDFs. My chatbot used probably around 18 PDFs, with each PDF roughly around 300 pages long, where each PDF was further converted into chunks, then embedding and then stored into the database. But you can also play around with web sources, Wikipedia, or other website links. You can play around with the cloud storage or the buckets as well. So once it was inserted, I can just quickly open and show one of the graphs that it generated. For this particular use case, I didn't restrict the schema to be less creative. I said, you are creative now, just design something for me. So just create some networks up there. Now, if I go back and show you how it works, so once the data is in the database, I can query it in a regular way, or I can just use this particular chat window over here as query. So I'm just going to ask some questions out here, just speaking some random questions, which is more like context questions than that. Hey, you have to move from Normanton on Collins Street to Legoland, Melbourne, and then you have to target what's the best way to do that. So hopefully I get a response. Otherwise, you can always play demos. It will work. Okay, so to travel from Normanton on Collins Street to Legoland, you can take this particular route, and then after visiting Legoland to Charlotte, you would likely use a combination of public transport options such as train and buses. You do this, and then you can go back and see where are you getting this response from, which identity is used, chunks used, blah blah blah. And stuff. I can just go into depth of it. It's just another context question which says that if I miss my last train, I'm not specifying what's the last train timing. I say that this is what if I miss my last train from Satyara, which trams are available to reach the city. Okay, if you miss the last train from Satyara, you can take tram route 58, which operates from West Suburb to Turak, passes through Satyara. This train can take you towards the city. I won't be able to see the response, but I'm sure this might be correct. Just going to the gut of it. So yeah, feel free to check on the accuracy. But moving on, that's how you would retrieve information and put it into graph using LLM graph builder tool. As I said, the tool is free. It's open source. You can play around with it. It's hosted on LLM-graph.com. Read the documentations. If you feel that some issue, the response is not great enough, there is something which is you add other more features, you can always raise a GitHub issue. You can also play with local LLMs if you feel that, hey, so we provide support for 3 LLMs at this point in time. Again, no key needed, no API key needed for now. But if you want to run with any local LLM, anything that you might have downloaded from Llama or from Face or anywhere, you can also just run it as a Docker file. Check out our GitHub, it's github.com/labs LLM graph builder. Just update the LLM and just play around with it. As simple as that. Okay. Almost closing my talk. So the next part on the governance. As I said at the start, like we've always been talking about hallucinations and how to avoid hallucinations using RAGs and bunch of other stuff. But what's missing when nobody's focusing these days is the governance and the explainability part. So you can control your entire information retrieval via the access control policies down to the node level using your 4J itself within the knowledge graph itself. And then on the explainability part, as you have already seen, that you can verify the response that you're getting by getting what are the data sources for that, what were the chunks used, what were the entities used in that particular response. So all about this is how the GenAI reference architecture will look like. If you look from left to right, the two arrows, one going from left to right and one from right to left. So left to right is where you're talking about the data ingestion. From right to left is essentially your retrieval part of it. You take data sources, put it into LLM graph builder or just write your own logic. Essentially creating a knowledge graph. Once it's in the knowledge graph, you can take any of the end user applications or use cases. Again, not restricted to them. And then just start with the models building the GenAI application. Last, leave you with a couple of resources. This is one, probably you might have to want to keep your phone a little handy. There's so many QR codes on the display. So this is one notebook that you can play around with on the GenAI workshop. The next one is some more resources on GraphRAGs and GenAI. For example, this is an excellent documentation page, native.com/labs/GenAI ecosystem. All our GenAI content is sitting in that particular documentation. Whatever integration that we build with LangChain, Llama Index, Haystacks, whatever is launching, it quickly gets updated over there. And then this is the link for our this is a shameless plug on the monthly contest. So whatever activities that we do across Asia Pacific, we are running a monthly contest to, of course, send you some relevant developer only resources, no marketing content, trust me. But yes, you can also be part of the giveaway if you enter into this contest. It's a nice giveaway. We give out either a drone or a master speaker every month. Okay. Last, no, wait, sorry, 3 more slides. This is Graph Academy, our one-stop solution for all the graph content. Not just on graphs, but the graphs will generate together as well. We have built a bunch of contents out there. Interesting questions, definitely would recommend to try your hands up. And then once you're ready, you can always take certifications as well. These are free certifications to try out. These are the course, deep learning AI course that we launched earlier this year with the MBO on class lab. For not more than 2 to 2.5 hours long course. And last but not the least is our Nodes conference. This is our annual conference where we bring in the entire graph content under one roof, happening virtually. 4 tracks, one particular talks this year, and we are getting amazing keynote speakers like this runs across all the time zones, with respect to being to America, so if you want to register to this over there. With this, I'll wrap up my talk. Thank you so much for listening to me. If you have any questions, we can take outside or if you have time. Okay.
So I'm not sure. You're the expert, so I'm gonna notice that I'm gonna struggle to make my question, right? But if we go back to like the single layer neural networks, we used to say that you have to be a domain expert to prepare the data, feed the network, train, and get the results. But if I got it right from your example, you got any simple PDF, you go into any Wikipedia page and you just drop it there and you're able to extract a graph. Now, can I just get an old book from 1950s and feed it there? It's gonna work, or do you expect some kind of structure in the input data so you get quality training and output?
So it's up to you. You can go with either of the options. So the chatbot which I made, the one that I talked about the Indian use case, I started off with structured data, but the tool was not giving me an option back then to do a graph analysis, where I can use only the structured data as a reference point, and then based on that generate more nodes and more relationships from the data that I'm giving you. So that was missing back then, but it's available now. So you have that option whether you want to use your structure as a reference point. If not, like for example, for this trans and trains example, I just directly gave the Wikipedia sources. There was no structure, there was totally blank database out there. So you just fix in nodes and entities and relationships from the data and started building a graph for you.
Very impressive.